everyone, welcome back. നമ്മൾ ഇന്ന് ഡിസ്കസ് ചെയ്യാൻ പോകുന്നത് സോളിഡ് സ്റ്റേറ്റിൽ നിന്ന് ഫ്രീക്വന്റ് ആയിട്ട് ചോദിക്കുന്ന ഒരു ചോദ്യമാണ് wherein they ask us the relation between A and R. Okay, R. Where A is the lattice parameter, നിങ്ങൾക്ക് ഒരു ക്യൂബ് തന്നിട്ടുണ്ടെങ്കിൽ അതിന്റെ ഡയമെൻഷൻ, ലെങ്ത്, ബ്രെഡ്ത്ത്, ഹൈറ്റ്, all are the same, അല്ലേ? So A is the lattice parameter and R is the radius of the atom. In solid state, we usually consider atoms to be spherical and അതിന്റെ radius. But depending upon the unit cell which is given, chalapa the simple cubic avam, SCC, or it could be body centered cubic, BCC, or face centered cubic, FCC. So depending upon that, the relations are depicted on the screen. A is equal to 2R, A equal to 4R by root 3, A is equal to 2 root 2R respectively. Then for this particular question, we'll discuss it in the end. But for the time being, let's solve this question, which was asked in CSIR 2012, June. Okay. Our question says, namukku thannittulladu oru face-centered cubic aanu whose lattice parameter is 4.04 angstrom. Nammal adinte atomic radius kandupidikkanam. Namukku ee relation ariyamengil the question is very easy. Endu matram cheyda madi? What we know is lattice parameter for an FCC cell is equal to 2 root 2 R. Alle? So R would be A by 2 root 2. Atrelo, we can directly solve that. 4.04 angstrom divided by 2 into, now root 2 is 1.4 approximately, this much. So if you solve this, you will get it as 1.44 angstrom. So the correct option is option B. Okay. In this relation for particularly FCC and all that we'll just see in this video. So what you have here is a cube which is face centered. Now face centered parnal, it will be having occupations like, I'll show the cube. Suppose this is a cube and face centered parnal, you will have occupations at all the corners, just to the miniature version ana, and also you will have occupations at the face centers. Okay, depict but please note that face center corners face centers occupy atoms the same. It should be the same. FCC. Okay, so top face, bottom face, left, right, back, and front. All face centers occupation. Now what I have taken here is only the front face. Front face, this corner, the opposite corner, and the center. You can see that they are coinciding with each other. They are coinciding. Now along this diagonal, this diagonal is face diagonal. This is the face diagonal. Pythagoras theorem that if this side of the face is A, if this is also A, if face diagonal in the from this relation, we can find that it is equal to it is equal to root 2A. Correct? Pythagoras theorem hypotenuse square is equal to base square plus height square. Rearrange what you get is the face diagonal is equal to root 2A. And what is this root 2A equal to? This root 2A in the see, it is the sum of 4 radii. This is R. If this is the center of the sphere, this is R. This is also R. And from the center, this is also R. Or else what we get here is root 2A is equal to 4R. Correct? Or A is equal to 4 by root 2 into R. And what we get here is A is equal to 2 root 2R. Correct? And that is what is written here. Now this is how we derive it. But for the exam point of view, all you need to by heart is these 3 equations. SCC, BCC, FCC. All right. So a similar question was asked in December 2013. Same very easy. They have given the dimension instead of lattice parameter. In the term, what they have used is unit cell dimension. So that's lattice parameter notated by A. A is given to be 4 angstrom, and they have mentioned about what they are telling us. They are telling about metallic gold. Other FCC crystallized question choichittulladu. And what they need is they need the radius of the gold atom in angstroms. So you can try this out and let me know the answers in the comment box. Thank you. Have a nice day. Bye. See you.